Hi, everyone, and welcome to Wednesdays at Noon webinar series. And as part of today's webinar series, we will be talking about information awareness of research data in STEM. My name is Jay Bhatt. I am the Librarian for Engineering and Scholarly Communications department here at Drexel University Libraries. Um, During this session, we will learn about instructional tips on how to find science and technology data using DRIDE, ICPSR, Google Dataset Search, and we will also try to explore some databases like Statista that we have subscription to, and then we'll try to explore different repositories, data repositories using re3data.org. We'll learn about keeping current about existence, scope, and features and availability of data repositories. Keeping current with such data repositories is critical in today's research environment. And this session will also help you to develop a methodology for teaching students and researchers about how to find and evaluate appropriate data sets. And this is important because many courses like engineering design or even other disciplines, when students are required to write a proposal for a particular problem that they are trying to solve or for a research paper, they need to support it with different data showing that there is a need for this particular situation or a problem that to be solved, and they need to find that data to support it. And even at Drexel, we all know that there are a number of interdisciplinary research areas, and because of that, whether it is in nanoscience or medical robotics, biomaterials, tissue engineering, biology, more and more research is done and more data is generated. And for that also, when they write funding proposals or research proposals, they have to support that using data. So discovering data sets and challenges of finding them is growing, and therefore it becomes evident that there's a need for faculty and students to develop information skills in finding and applying data in project and research papers. So what are some ways of learning how to find and use data? Let's ask that question to ourselves, and let's see what we can do and how we can help you discover the data. We will talk about relevant resources available from the library. You can also include them in your library guides, and we also have created library guides where such data sources are included. You can embed your library guides in course management systems. That will be a great way for students to discover. We can also do workshops on data sources in your classes. And student associations can also work together with us to do a presentation for all students. And then it will help them students find data, interpret data, analyze data, apply that in the project assignments, and we'll take examples in today's session using practical examples like finding data on climate change, global ocean pollution, and how it can help in envisioning solutions. Here is an example of a library guide that I have prepared for our civil architecture, environmental engineering students, in which they also need to find data. And you will see that there is a section on environmental data there, in addition to books, electronic books and journal articles. And a lot of times, data is also presented into journal articles or even in thesis and dissertations. So there are a number of ways that they can discover data. And here is a screenshot from the same page where environmental data are discovered. And I have included them in one place. Now environmental data and renewable energy data, geospatial data, national renewable energy library data, and so on. And considering the increased emphasis on climate change, sustainability, renewable energy, energy storage kind of initiatives at Drexel, I thought that maybe I'll take that as an example and see what we can discover. Here is an example of data sites from National Renewable Energy Laboratory. And when you go to this website, there's a whole section on data and tools, and you will see data on bioenergy, on buildings, on power, energy analysis, hydrogen and fuel cells, wind data, water data, and so on. I'm not going to go into details of it, but I suggest you go and explore by going to this website. And it's not just engineering or environmental science or physics and biology, but there are a number of other disciplines where discovering data is important, like in economics, financial data, social and economics data. So we'll try to cover some of that as well. Global data sets generated from all over the world, enormous. So the data is not just here in the US, it is generated from all over the world from the agencies. And some of them could be really excellent data sets that we can also use. So using journal articles, using databases, using repositories, using disciplinary data repositories like authoritative.org, we can explore those data sets. We also have a library guide on finding repositories from research and data management sources. And under sharing research, you will see a link to Arthi data and the other repositories as well. And these library guides will be updated. So please take a note of this because it could change in future with some additional information or refined information. Finding repositories. So we have examples of authoritative.org, global repository that includes data repositories from various academic disciplines, DataVen, NIH, public library of science recommended repositories, scientific data repositories recommended by scientific data. Repositories on this list have been evaluated by scientific data, ensure that they meet the requirements of data access, preservation, and stability. And you can simply click from this slide here. We will look at some other examples of data repositories like ICPSR, DRIDE, and then continuing on. So let us start with ICPSR. Drexel is an institutional member of ICPSR, which provides support for archiving social science and public health related data. And the mission statement advances and expands social and behavioral research, acting as a global leader in data stewardship, providing rich data sources and responsive educational opportunities for present and future generations. So we strongly encourage you to look at find data and share data from this site. We have access to ICPSR that can be from our library homepage. Under databases, you can find that link. And also on the previous slide, you will see the link. So you will see some examples here that some statistics about how many studies are integrated here under find data site. And most popular type of searches that our researchers have done includes COVID-related research, mental health, social survey data, and social media, and so on. Using DRIDE Digital Repository is another example of DRIDE Digital Repository where you can find discoverable, free usable, and citable data set. And there are some important features of DRIDE are included here that you can read it later on. But most important thing that I would highlight is it promotes data visibility through usage and download metrics and by allowing content to be indexed and search and retrieved. So you will be able to cite that data also. And here are some example. I'm using climate change and sustainability, but I know that a lot of nano-related data can be found as well. So nanoscience related, nanotechnology related data, nanomaterials related data, all of this can be discovered through our data repositories and through journal articles. So here is one example I used for climate change and sustainability. And you will see some examples of data sets here, and you can select any of your interest, and you will find a data set like climate change drives spatial mismatch and threatens the biotic interactions of the Brazil nut tree. Very specific, but that is what is all about. There are very specific data sets can be found here using climate. Again, we are talking about climate change and deforestation and how those data can be discovered. And here is the particular link, and this is where you can download this data set. And it also gives you some metrics, how many downloads have been so far. US government's data.gov, another fantastic way of discovering whether energy related or climate related data that you can start searching. You can also look at data visualizations using that. Here's data.gov. Just simply type data.gov, and you'll be able to use US government data from a variety of government agencies. Department of Energy data can be discovered there also. And the most important thing I want to highlight is using advanced Google search technique. You can find data sets in any discipline you want. And why I'm saying this? Because what happens is people usually go just to google.com and they expect to find all this information very quickly. Of course, we have a lot of databases that we have access to, that we subscribe to. We're going to look at it also. But before we do that, I just want to give an example how using advanced Google search, you can find ocean pollution data, for example. Instead of ocean pollution, you can say something like supercapacitors, for example. And if there are any data about supercapacitors you want to discover, you can use that. Key thing is you want to use site domain. Don't use .com. At least you want to discover quality data sets coming out of well-known organizations or educational institutions or government agencies. So you can use .org or .edu or .gov so that you can specifically find data sets from quality websites, and you're not bombarded with thousands of commercial sites if you just don't filter by this. So I'm using .org, ocean pollution data, and you can see that it takes me to this advanced search page limiting to .org websites only. And you can also simply type in Google. So if you're interested in carbon nanotubes and drug delivery kind of data, then you can use that keyword and then put site, then colon and dot. And if you want GOV, then it will find data generated from the government websites. You can also type .drexel.edu or .mit.edu or any universities where you want to discover data coming out from. So we can filter by it. And this helped me find this particular data set from our worldindata.org on plastic pollution data. This is a big deal because how plastic pollution and ocean pollution is really impacting environment pollution in a way. So this is the whole data sets that you can find here. Our world in data, plastic pollution. And from this website, I see that plastic waste generated in coastal regions is most at risk of entering the oceans. Also almost, and that was in 2010, and it should be even more now. Within 50 kilometers of the coastline amounted to 99.5 billion tons of plastic. And only plastic waste which is improperly managed, mismanaged, is at significant risk of leakage to the environment. And so you can see that this is becoming a very critical issue in oceans also. And here is a nice little chart, which is um, also from our worldindata.org. And this is a little more recent in 2015. And mismanaged coastal plastic waste 31.9 million tons per year, plastic inputs to the oceans 8 million tons per year, plastic in surface water 10,000 to 100,000 tons per year. So global plastic waste has gone up to 275 million tons per year. Now, why this is important? Because we have students working on senior projects. They could be interdisciplinary projects. They need to think about a solution to find and mitigate this. So it could be a PhD research work, it could be an undergraduate research, it could be just faculty researchers trying to write a paper for a publication. So they can all work together in a multidisciplinary area in that sense. Right. So this is something. So I showed you an example of advanced Google search. Now I'm introducing you to something additional dataset search that Google has come up with, which is called Google Data Search. So this is the URL where you can then search for data search option, finding data through Google Dataset Search. Again, we are focusing on ocean plastic waste as an example. So I just typed my keywords and that pulled up concentration of global plastic waste ocean by region 2017. That keywords are automatically generated, but if you don't want to use this, just use ocean plastic waste and click on search. And I found a more recent data. Now, from 2019, share of ocean plastic waste inputs worldwide 2019. And it is also updated on 2021. So now we found an old data. We use Google Dataset Search to find more recent data, and it tells you that it is available to something called Statista. So what has happened is Google Dataset Search is linking to a dataset site where this data can be discovered, which is through Statista. And we have subscription to Statista. We will look at it soon. And Statista is a subscription database that the library subscribes to. And here is the link from where you can find the data. It's the largest available data aggregator, more than 18,000 sources, both within the US and international data, and more than 1 million statistics you can find. So, and we are using ocean polished data as an example. So can Statista help in finding data on plastic pollution in oceans? Yes, because we did find a link to Google Dataset Search, which is taking us to our Drexel Library subscription. So we, instead of just going to statista.com, we went to Drexel University Libraries, and under databases by title page, there was a link to Statista. We click on that. So please do that, because it is an IP authenticated system where you'll be asked to enter your Drexel email ID and password, and you will be able to discover data. For a material scientist, we have a lot of data about materials, material properties available through databases like Access Engineering and Novel, and of course, Engineering Village. And if you go to our Drexel Libraries page and under Library Guides, within Engineering section, you will see a link to Material Science, Mechanical Engineering Library Guide. Within that, you will discover Access Engineering, Novel, Engineering Village, Scopus, Web of Science, and other important electronic book collections, including Novel, where you can be able to discover material property data set. Material properties, you'll find shear strength as an example of different materials. So you can explore those type of material property data as well. But we're coming back to Statista, our ocean pollution data. Here, I went back to that link, share of ocean plastic waste input worldwide 2019 by country, and I can be able to click on that link and find data here. So distribution of global plastic waste is emitted to the ocean in 2019 by different countries. There's a PDF download is also available, where it is coming from, that particular source, who is publishing it, and source link. All that is available through Statista here. Interestingly, this is also linked to our worldindata.org. So Statista is also linking to this particular site. So how these different data repositories are linked among different data sets, pointing to other directions so that you can discover data. And another global waste found in oceans 2020 is another data set that we found. So data awareness and outreach is important. We need to educate our faculty and students and researchers who are involved in teaching as well as researching information to develop awareness about existing data repositories. We have library guides, as I mentioned. We can do workshops. We can do partner with student associations and teach them how to find data. We can embed ourselves in different courses, and our librarians can also provide their insights in their appropriate disciplines. Now, we want to talk about some subject-specific disciplines. And this particular site, Data Repositories in Different Disciplines, is a great way to discover repositories in various disciplines like chemistry and all. And I'm giving example of chemistry here. So you will see Cambridge Structural Database, chem synthesis, e-crystals, and so on. So like chemistry, there are many other disciplines. Even engineering and material science repositories are available as well. And you can explore those. Now we will look at authoritative.org and explore what kind of information that we can find. authoritative.org, Registry of Research Data and Repositories. Again, I'm looking at ocean pollution, and this very interesting data site that I found in Copernicus Environment Monitoring Service. And you can actually see a lot of different subject areas covered: life sciences, geosciences, physics, chemistry, biology, oceanography, some brief information about data. I strongly encourage you to learn about this filtering option here, so you can see what kind of licenses, database licenses are available. And here is one example, just a screenshot from Copernicus Marine Service. Free and open marine data insights to enable marine policy implementation, support blue growth and scientific innovation. You can be able to actually look at a visualization into 4D digital oceans through our 3 visualization tools for beginners. And there's an access data link here that you can try. And one example that I found here is Copernicus data is also used to study species such as turtles and elephant seals. So again, we are looking into now biology. So a lot of interdisciplinary data that we can discover if you know where to access this kind of data from. Now, here is, if you look at subject areas here, if you go to click there, I know it is very small, but there is a whole area for engineering and sciences, humanities and social sciences, life sciences and natural sciences. So if I look at engineering and sciences section, you will see there is a whole group of material science data here that you can also explore. And if I go to another humanities and social sciences and history, there's a lot of religious history data that you can find from humanities and social science perspective. The point I'm making is data is available in all disciplines. It is important that you learn how to access and find data in your particular discipline using repositories like archidata.org or ICPSR, for example. And this is a database of religious history, and that takes you to religiondatabase.org. And you can actually look at early modern history, modern current history, medieval history, ancient cultures, that kind of interesting data that you can capture. And this is the world's first comprehensive online quantitative and qualitative encyclopedia of religious and cultural history that is available through this, that we discovered through archidata.org, and browse the database. And the additional data that you can discover, this is latest as of April 2022. You can see African churches and so on, different types of data that you can search here. And this was my last slide. And you can go to library.drexel.edu, for example, and that will take you to our main library homepage. And if you go to library guides example, you will see all different disciplines here available. Or you can just simply type data management, for example, to discover all library guides, research data management resources. And this is the website I mentioned earlier. And if you click on share research, then you will see authoritative.org that you can find. If you go back to library guides, and if you click on engineering, for example, you will see material science, materials engineering data, or you can go to engineering, for example, and you can see electronic references. Now we have access to access engineering case studies online. Or if you click on electronic books, and that is well, you will find novel data for finding materials property data. And under electronic databases, you will find access to Engineering Village, a semi-digital collection, IEEE, Scopus. All major databases are discovered. So this is a quick way to accessing our library guides in different disciplines. And let us see if you have any other questions. Thank you so much. I really appreciate joining me here today in the exploration of different data or different information that you can find. And I strongly believe in interaction with students, faculty, and researchers. So by active dialogue, we understand what your needs are. We ask you questions, you ask me questions, and that helps us together discover the right source of information for you. Thank you so much.